welcome. This video is about piecewise functions. This is at the highly proficient level, and they're asking us to write the equation for the graph below. So we're talking about different x domains. We're talking about different domains. That's always x. So let's look at this part right here. What are the different pieces? Well, this piece right here is obviously one of those. And this part right here is all of these are x values that share in common the same x values with that part of the graph. And we could call that, since all of these are x, this is 1, we could say that it's less than 1. We could say x is less than 1. There. That's this portion right here. All of that is x equals 1. And so this part over here, so color that in here. This is the other part. You can see this is the other line, the other part of that line. And all of these points that I'm marking have the same x values as that part of the line. And so we could call that, well, x greater than or equal to 2. Now, if we wanted to, we could have said x less than or equal to 1, and then x greater than 2. But you only want to have, not 2. This should have been 1. Come on, man. All of these should have been 1. So x greater than or equal to 1, or x greater than 1 strictly, or x less than or equal to 1. So you only want the equal to at the kind of that boundary line on one of them or the other, so that we're consistent with just having one x value in our function. So put it on one, put it on the other. Sometimes in other more advanced functions, you might see something where it comes up kind of like this, and then has a dot, and then down here there's a circle. And so the equal to part would be here, and the strictly less than part would be up here. I guess in this case you could say this is the greater than or equal to part would be this. But the equal to, that little line there, goes with the one with the dot. Anyways, that's not what we have here. So you just want to make sure that you either put it on one or the other, and that's okay. Where they come together at the same point, it really doesn't matter. So then let's look at the top one, the blue line. This is a horizontal line. And so everywhere that is consistent on this point, this is some point, let's say this is -5, 0. This point right here is -3, 0. This point right here is -1. Sorry, guys. None of that's right. Excuse me. Sorry. It's -5, 3. It's early. I'm sorry. -5, 3. And this is -3, 3. And this is -2, 3. And this is 0, 3. And this is right here is 1, 3. What do they all have in common? Y equals 3. So f of x, which is y, is equal to 3. The y value is 3. Here y is 3, here y is 3, here y is 3, here y is 3. Everywhere 3, y is equal to 3, but only the y. X will change. Let me erase those. So what we know is that y equals 3. But here we see this is a linear equation in which there is some slope other than 0, We can assume this is going to continue off to the right. This would, had it been allowed, would have gone up here through that value of 4. And that means that if we put this in the form y equals mx plus b, that value there would have been 4. And the slope is rise. The slope, or the m value, is rise over run. And this is going, if I go over x, that's a run of 1, but it goes down 1. So that's negative 1 over 1, negative 1 over 1. And so then I can say that my slope, negative 1 over 1, is negative 1. And so I've got negative 1, or just negative x. Negative 1x is the same as negative x, so I like the simpler version. And so y equals negative x over 4. This is then negative x plus, not over 4, plus 4. Negative x plus 4 if x is greater than or equal to 1. And so again, you could write that same thing. Y equals 3 if x is less than or equal to negative 1. Or excuse me, less than or equal to 1. Or negative x plus 4 if x is greater than 1. Either one of these options, either one of these two answers would be acceptable. So there you have it. Have a great day.